you will have alpha floor detections in case of high angle of attack or low energy warning during the takeoff. It is very short time phenomena, low energy warning. All these things will be computed by the FAC. FAC also compute the weight and CG of the aircraft. Right? Speed computations. Speed computed by the FAC are sent to the PFD, and speed limits to the FMGC. In the normal mode, FAC1 will display on the PFD1, FAC2 will display on PFD2. That's a normal configuration. Whatever the speeds are calculated by FAC1, it will be displayed on PFD1. The speeds calculated by FAC2 will be displayed on PFD2. Okay. If parameter or one computer fail, then the other computer will supply the information to the other side automatically. If the air data used by the FAC is different from the other source, it means there is a difference between the two side parameters for the display. Then from the different source used by the DMC for the speed display, then message will be ADR disagree will appear on the ECAM. ADR disagree. You might have seen the various disagreement messages. Speed disagreement, altitude disagreement, right? Heading disagreement or check heading. These kind of messages are displayed on the PFDs when there is a different values on both PFDs. For the heading, for the altitude, for the air speed, for the attitude. So ADR disagreement will appear on the screens. Speed computations are basically a functions of the aerodynamic laws of the aircraft configurations. And the computations principle is based on the fact that most of the speed, aircraft speed is calculated at what basis? The speed is calculated based on the weight on aircraft, correct? And drag. So the drag will be created by various reasons. Maybe with the extension of the flight control surfaces, maybe extension of the landing gear, and actual weight on the aircraft. So many things calculate the speed of the aircraft depending upon configuration of the aircraft. The computation principle is based on the fact that most of the speed data are a function of the aircraft weight. In flight, FAC will compute the weight of the aircraft with the help of ADIRS. FMGC, slat flap computers, and then from the weight. It computes the characteristic speed and CG. It computes the characteristic speed and the CG on ground. FAC will uses the weight given by the FMGC. So how the FAC will compute the weight? That will be given by FMGC on ground. It means on ground there is no weight calculation. How the aircraft calculate the weight of aircraft? Any idea, guys? Or how the pilot fly with the weight of aircraft?
Depends on speed and angle of attack.
Okay, that is in flight. But on ground, let's say aircraft is going to fly. So how does he know the weight of aircraft?
The weight is given by the loading officer. Calculates everything, everything on the cargo, fuel, empty weight, number of passengers. Yeah.
Correct. So basically the loaded sheet is there. Yes, Mr. Ozifa. Ahmad, go ahead.
And the basic weight for the aircraft, and he has all the data for the zero weight and.
So how we get the weight of the aircraft? That is a basic or empty weight figure will be with him.
Yes. So
But
he
how
entered
the
all. He put all this data on the FMGC. Then it will calculate the total weight of the aircraft and the power required for takeoff and
Yes. So basically, the pilot get the trim sheet. That load and trim sheet carries the total cargo weight. It carries the weight of the passengers. Correct. So this is the additional weight. Fuel and hydraulic fuel, they get the fuel figure, so they calculate the fuel weight also. Right. So fuel, how much onboard fuel onboard is there, which is actually measured by the fuel quantity indicating system. So remaining is the aircraft normal weight, considering the fluids, hydraulics, aircraft empty weight, barabar or zero fuel weight. That's how they calculate the weight of aircraft before takeoff and then apply the appropriate thrust. Correct, sir? In flight, when the aircraft fly, then with the help of ADIRS, in a clean configuration for some time, it is not clean configuration. The clean configuration in the cruise condition, when the parameters are stable at a given speed Mach, then PAC will compute the actual weight of the aircraft, and that will be given to the FMGC. Right, and subsequently, then aircraft keep on working with that weight, because the weight is continuously changing. Am I right? So pilot will not maintain the speed, or pilot will not keep the speed constant, because the weight is continuously changing. If he maintain the throttle at one point, speed will keep on increasing because the weight is reducing. You got my point?
yes.
So hence FMGC will take into account the actual weight of the aircraft and then monitor the thrust or monitor the speed. So this is how speed computations is done. Why the FAC? Speed computations is done by the FAC. Both the FAC will do this job. To calculate the speed, they take the input from these places, right? ADIS, FMGC 1 and 2 information. SFCC will give you the clean configuration or not clean configuration. LGCIU, whether the landing gear is extended or not extended. Accordingly, various speed computations will be done. And from here, it will be given to all three DMCs. Right. And then the DMC will display on the respective PFD scale. If you will see some of them here, you can see this is the speed scale is available. Index, which is a pointer. This is the current speed or actual speed. The trend arrow is showing here that what will be the speed after 10 seconds. So it gives an idea to the captain that how he's going and what will be the speed after 10 seconds. The red zone shows that this speed is prohibited. Aircraft should not fly in this speed in the given configurations. So this is all nice to know information. Mainly it is used by the captains, not by us. Alpha floor and wind shear. Before I go with the alpha floor and wind shear, I'll use my own presentation to explain you the alpha floor and wind shear. Very closed small area. This can happen, or this can have an adverse effect on the aircraft performance during takeoff and landing only. Once the aircraft is above a certain height, it will not affect. The FAC will generate the wind shear warning whenever the energy of the aircraft falls below a predetermined threshold. That means the energy of the aircraft is going below a threshold, then it will generate. There is no sensor available for the wind shear. It is only calculated by FMGC. But when weather radars, that function is available in the weather radar as a predictive wind shear. Have you heard about PWS? and RWS. So FAC is mainly doing the RWS, reactive wind shear, while the weather radar is able to calculate predictive wind shear. So as I'm talking about the FAC, it is a reactive wind shear. It means when you are into the wind shear, then only you detect it. And then pilot take the corrective action. So this is a reactive wind shear. But in today's time, the weather radar information is available. So jointly with the FAC and weather radar, they give the predictive wind shear. Okay. So we'll see both places. And this is what the phenomena is. It's a very short-term phenomena. Wind shear. High speed wind will come to the ground. They will hit the ground. And then the vortexes will be created. And these vortexes are going in a. You got my point? Now, consider aircraft is falling in this category during takeoff and landing. What will be the situation? Let's say aircraft is taking off. So it will nose lift. Sometime it will down, and then further go down, then it will go up. So it is, roller coaster ride for the aircraft. You got my point? And that phenomena happens during takeoff and landing, and the area is very small. This wind, let's understand with example. This is the wind shear. It is an airport, and you are at the runway here, right? Now in the reactive wind shear, the zone is very small. This is the limited zone for the reactive wind shear. Okay. So the pilot will take the action only when he is in this region. That is 0.5 nautical mile, which is nothing. So chances of accident is maximum in the reactive wind shear. But in today's world, the wind shear function is available with the weather radar. And in this situation, you can get the warning as early as possible, 3 nautical mile before the runway threshold. You get warning 3 nautical mile before the runway threshold. Clear? Hello?
Yes, sir.
Yes, sir.
And a height of 1200 of the ground level. So much before the impact of wind shear. Much before the impact of wind shear, you get the warning. And you can take the corrective actions. Corrective action is nothing but toga. Take off and go around. Just fly away. There is no other option. And wait for the time to come. When the environment is settled, then you come back. So in this region, when the aircraft is descending up to 1.5 nautical mile, you get the caution, take corrective action. Once you cross this area, you are falling into the warning region. And as you are going closer, it is getting difficult for you to escape. Understand the phenomena. How does it happen? With an animated couple of examples. So you are on the takeoff and the downward drift is coming. Normally it appears normal. Now you are in the takeoff, but the downward drift is coming. So what happen? It will try to. You got my point?
Yes.
The downward force will put your aircraft down, nose down. Subsequently, aircraft speed will increase, so the pitch attitude will also reduce, and then probably it will collide on the runway. This is a one phenomena. Another phenomena, initially takeoff, right, airspeed so due to the wind shear. It means wind shear action is there, or wind shear phenomena is there. Aircraft is taking off, but it is not able to gain the altitude. Speed is building up slowly, but it is not able to gain the altitude. So subsequently what happens? It will take off, right? But it will hit the nearby ground structures, buildings and all these things, because it could not develop the altitude and speed. So airspeed reaches VR. VR is a rotate, V rotate. I will show you the video to understand V1, V2 and VR, all these speeds. Airplane reaches VR near end of the runway. It means you could not gain the altitude. You got the VR at the end of the runway, right? So it is difficult for the pilot to get the altitude. And you all know that airport boundary area are mostly the commercial areas. Airport boundary areas across the world are mostly commercial areas, too big, right? You will have a large, tall structures, buildings, right? Hotels, so many things are there. Even airport installations are also there. Probably there is a chance that it will hit the ground structures. Subsequently, let's say you are third configuration, you are in landing. You are following the optimum descent path. You are following optimum descent path. The moment you come into the wind shear phenomena, right now what happened? All of a sudden you will go because below the glide path. All of a sudden you will go below the glide path because of downward drift. Correct? And you will hit the runway or maybe the paddy field before the threshold area. So these kind of situations happens when there is a wind shear phenomena. The reactive wind shear system react to the aircraft being in the wind shear, and predictive system such as weather radar looks ahead to predict wind shear. Warning in advance, headwind or upward. This may lift the aircraft above the glide path. Pilot may react by reducing the upward. The aircraft will enter into the severe downward drift. So as I said, it is a roller coaster movement for the aircraft. At this point, it may be too late. At this point, it may be too late to develop the thrust required to escape before sinking to the ground. Okay. How the pilot will come to know wind shear? There are the two ways the pilot will get the alarm for the wind shear. First alarm, the synthetic sound will come as a wind shear, wind shear, wind shear. That is a synthetic sound. 3 times it will come from the cockpit loudspeaker. And on PFD, you will see the red color wind shear message. I'll show it again.
Wind shear, wind shear, wind shear.
Right. So this is how the pilot will come to know. FAC will compute the wind shear from the ADIRS mainly. Parameters are taken from the ADIRS, that is the vertical speed, air speed, ground speed, total slope, longitudinal wind gradient, vertical wind gradients. All are provided by the ADIRS. Warnings are wind and synthetic sound will come wind shear for 15 seconds. 15 second wind shear warning will come. Yes, Dhanuka.
Sir, that sound will come during wind shear or before the wind shear? Like predictive wind shear or reactive wind shear or both?
I can't hear you, my friend.
Can you hear me, sir?
Yeah.
That sound will come. Is it during the wind shear or before the wind shears?
During wind shear. The moment it detect.
Oh, yes.
It's not like you are in the wind shear and then it will tell you wind shear. The moment it detect whether it is a reactive or whether it is a predictive. So whenever detection is there, it will warn you.
Okay, sir.
Now, in the next figure, you will see where it is detected. Go around thrust to be set immediately manually by the pilot. Which order is to be followed to execute the optimum escape maneuvering guidance? It means There is no other option than to fly away. Just apply the toga and run. Okay. So this phenomena is applicable from liftoff up to 1300 feet, on takeoff, and during approach 1300 feet to 50 feet. So this is the operational range. After this, it's not effective. You got my point? This is the operational range of wind shear. It means from liftoff to 1300 feet, during approach 1300 feet to 50 feet. Once you are at 50 feet, you have to land. There is no option. Clear, sir? You can perform the wind shear test from FMGC. So when you go to the FMGC menu, auto flight system menu, right, there is a AFS test, land test, and wind shear test. Correct? So when you click on the wind shear test here, it will perform test by both FAC, one at a time. So this test will repeat 2 times. Before that, it will ask you to perform certain actions like both engines should be stopped, all brakes should be applied, FAC 1 should be engaged, FAC 2 should be off. Right? On switching panel, make sure that the air data switcher Captain 3 system is in configuration. So you are using ADIRS number 1 to number 1 system, number 2 to number 2 system, and number 3 is standby. So that is something you have to keep in mind. All these instructions are given on the MCD. You have to just follow. When you go with this, now press the test key, right? When you perform the test, it will ask you to check on the PFD that you saw the red warning message and you hear the sound 3 times, wind shear, wind shear, wind shear. If you have done it, very good. Press yes. And then, sorry, it is asking you to observe all these things. Perform the test, right? When you perform the test, did you hear all these? Yes, very good. Now repeat the same thing with FAC 2. So now you have to do the FAC 2 engage, FAC 1 off. That is reverse of this area. Clear? So earlier we have done the test from the FAC 1. Second time we will do it from the FAC 2. Okay. And system will continue. Once you do from both, it will show you the wind shear test is okay. Am I right, guys?
Yes.
Yes.
Low energy warning is software function. So FMGC or the FAC will calculate it automatically, which gives the crew an oral warning. This warning indicates that it is necessary to increase the thrust to recover a positive flight path. It means to recover again because aircraft is sinking. What's happening in the low energy warning? Aircraft is sinking. Aircraft is not able to gain the altitude after takeoff. Right? Positive flight path angle through the pitch control. Oral warning is triggered when the aircraft energy level is going below threshold. No energy is available to alter the flight path trajectory, so to maintain or gain altitude. So what happened? FAC will generate the warning speed, speed, speed. Synthetic voice will come repeatedly every 5 seconds. FAC will compute low energy warning from aircraft configuration, horizontal deacceleration, and flight path angle. Actually, it is a primary phase of
Speed.
wind shear.
Speed.
Low energy warning is nothing but it is a step before stall warning. Correct? A few steps before the stall warning, this is the situation. So you can see the synthetic sound when this generated.
Speed. Speed. speed.
So a scale will also move to give you the commanded speed that you have to fly minimum this much of the speed. Okay, low energy warning is inhibited. When it is inhibited? When you have applied the toga, because you have applied the maximum thrust, you cannot do anything. So the warning will not come. If aircraft is below 100 feet radio altitude or aircraft is above 2000 feet radio altitude, this warning will not come. So this warning will come between 100 to 2000 feet. So it's like a wind shear phenomena. Once you are in air after a certain altitude, it will not be. Or if alpha floor is triggered, then it will not be there. Or any GPWS warning is there, it will not be there. Or your both altimeter fail, it will not be there. Correct? So these are the conditions where low energy warning will not be there, inhibited. You will not get the low energy warning in these conditions. What the pilot will take the action? The auto thrust, the thrust is to be increased in order to regain a positive flight path angle through the pitch control. Clear, guys?
That signal?
Yes, it originates from the FAC.
Okay.
Yeah, because the FAC has this function. So they will
Alright.
generate all these warnings.
Okay.
Right, sir?
Okay, sir.
So alpha floor and wind shear, alpha floor, high angle of attack. FAC will compute the high angle of attack with a predetermined thresholds function, which is a function of the slat and flap configuration. If this threshold is exceeded, the FAC will send a signal to the FMGC to engage the auto thrust functions and apply full thrust. I think if yesterday instructor have talked to you about auto thrust manual operations or auto operations, then he must have discussed this. Irrespective of whether it is auto thrust, whether it is a manual thrust, wherever the levers are, it won't care. It will automatically apply the toga thrust. FMGC will automatically apply the toga thrust. Correct? It will not see where your lever is, right? Whether your lever is at flex or climb or below the climb or above the idle, wherever it is. In alpha floor conditions, the thrust will be automatically commanded to toga thrust within certain altitude limits. All right, give me a second, guys. Asking something.
So just one thing, for the automatic toga on the auto
Okay.
flight, the altitude range will be the same as 100 feet below. It won't happen under 100 feet or above 2000 feet.
Below 100 feet, it will not apply. Below 100 feet radio altitude, it will not apply. Right. During approach. If you are in takeoff configuration, the whole sky is open. You can go anywhere.
Yes. Okay.
But if you are descending, you are nose down.
Yeah.
And you apply the toga at nose down, you will crash. The aircraft will be like a rocket.
Yeah.
Right. So you cannot control. It will take a less than second or less second. Pilot won't be able to react. Aircraft won't be able to react it in that situation. So that's the purpose. Okay. So if the threshold is exceeded, FAC sends a signal to the FMC to engage auto thrust functions and apply full thrust. When alpha floor protection is no longer active, the thrust will be logged and that will be shown as a toga log. The thrust will be logged and that will be shown as a toga log. Correct? So how to come back from the toga log? The auto thrust will be engaged, disconnected manually. Understand this operation. Let me tell you. Understand first. Let's say aircraft is flying with a manual toga. Manual thrust, sorry. Correct. Lever wherever it may be. Let it be. Let us say the lever is at the climb detent. Okay. Do you remember all the detents on thrust lever? Idle, climb, flex, and toga.
MCT together.
Correct? Four detents are in the forward section. Idle, climb, third is a flex MCT, and fourth is a toga. So now let's consider your levers are at climb detent. All of a sudden, high angle of attack is detected. Your lever is at climb, but FMGC has automatically commanded to FedEx a toga thrust, and you will see it will activate as toga thrust. Maximum thrust will be applied. Aircraft will boom go up like a rocket, and once you are out of the angle of attack, pilot will level off. Correct? When there is no high angle of attack, pilot will try to level off, but your toga is locked. Your thrust, which is going from the FMGC, is a toga thrust, which is very high. So what the pilot has to do, he has to disconnect the auto thrust manually, and the key come to the lever position. You remember the lever position and the auto thrust, what is the difference?
Yes.
What is the role of the lever?
Lever will remain.
In auto thrust condition, what is the role of the lever?
The position won't change.
Okay, that is the one thing. That is good for me. What else?
So it will active the auto thrust actually. Position.
It should be on the climb position.
Okay.
Hopeless.
Between climb and MCT.
Mm.
Okay.
The twins are there.
No, he has already covered. So anyway, let me go back to explain you. That area is already passed, my friend. Okay, let's see from here. Okay. See, during auto thrust, pilot will keep both the thrust levers here, which is a climb detent, right? This is a standard practice. A standard practice, they will keep the lever here. Okay. Now, the FMGC is calculating the auto thrust because it is in engage and active mode. This is in this mode. Engage and active mode. So it is applying the thrust based on calculation. But at the same time, wherever the lever is there, lever position is also coming to the FedEx. And auto thrust command is also coming. So does this lever has some importance in auto thrust condition?
Yes.
What is the
for
importance?
disconnecting?
When autopilot will disconnect, the system will take this position for the thrust.
When system auto thrust will disconnect, the system will take this position. Yes, you can say correct. What else? What else? I'm looking for some specific answer. That is one of the function. Although it is an operational question, but to understand the
गाड़ी से
topic,
जा.
I'm emphasizing. Yeah, Anand, you're saying something.
I'm sorry. I'm sorry I interrupted you.
No. If you're saying something, we are hearing you.
No, I'm sorry, sir. I was speaking to my mother.
Okay, no problem. So listen, guys. This lever position plays a very important role, even it is in auto thrust condition. Even it is in auto thrust condition, it plays a very important role. What is the important role? I'll show you with an example. Let us say you are flying at 300 flight level. Okay. This is your flight level 300. And at this time, let us say you are flying with 28K pound thrust. Just understand the example. You are flying with 28K pound at 3000 flying level. And maybe the climb detent is giving you, let us say, 29K pound limit or 30K pound limit, which is equivalent to lever position in manual mode. Are you following me?
Yes.
Okay, it means actually your lever is at climb detent, but FMGC is giving the command up to this level, somewhere this level. This is 30, so somewhere this level. It means your lever is at higher position, correct?
Yes.
Very good. Now, pilot has to fly to 360 level, flight level. Means 36,000 feet. So what happened? He will climb. Correct?
More power.
Aircraft will climb.
He need more power.
You need more power. Very good. Now let us say it might need 31K power. Got it? It might need 31,000 pound power to reach up to the flight level 360. But what your climb detent says?
30.
30,000. Just a minute. You understand this? Now, here you need to pick up the catch. The lever is at maximum 30,000 pound and the requirement is 31,000 pound by FMGC. This is a requirement by FMGC. FMGC cannot give the command more than 30,000 pound. That is a problem. FMGC cannot give the command more than the physical value of the lever in auto thrust also. Are you getting me, guys?
Yes.
Yes.
So the thrust lever plays a very important role even in auto thrust condition. So let's say your lever was here before high angle of attack. Auto thrust is applied the thrust up to toga automatically. Correct? Your lever was here. It applied the auto thrust in high angle of attack. After applying this thrust, aircraft climb out of danger, but your thrust is toga. Your thrust is toga. So this is a problem. So what pilot has to do? He will get the message here, toga lock. What message he will get?
Toga lock.
Toga LK. Toga lock, he will get the message here. So pilot has to disconnect this. Click, disconnect the auto thrust and then FMGC plays the role, or sorry, FedEx will place the role to bring the thrust slowly to lever position. Otherwise, there is a big jump.
Yes.
There will be a big jump. So that is a function. The thrust will reduce slowly from toga to lever position, wherever it is. It may be here also. It may be here also. Right? Lever can be here, lever can be here, lever can be here, anywhere. So the thrust will slowly reduce to the lever position. I hope this is clear. Clear, guys?
Yes, clear.
So just wondering, in case the aircraft is asking for more power and the
Okay.
thrust lever is somewhere down.
Yeah.
So in this case, it won't be a good situation, right?
Yes, you are right. But during takeoff, because the maximum thrust required in during climb and change of flight level, climb is okay. Climb thrust is sufficient. Unless you are going for escape maneuvering, you want a more power, so he has to go manual. In auto thrust, he cannot go.
Yes.
Right? Let us say TICAS warning came. Angle of attack is taken care by FMGC. But let us say TICAS is there. Right? Or pilot saw something on the ground and he want to go around. He has to go manual. So he has to move the lever.
Yeah, I got it. Yeah.
Correct?
Yeah.
So as far as auto thrust is concerned, the climb is the maximum limit for single engine operation. Sorry, double engine operation. If you are in single engine operation and want to get auto thrust, then you have to keep the lever at maximum up to the flex.
Yeah.
You will get the full range of auto thrust up to the flex. Is that clear?
Yes, sir.
Yes.
So, sir, is it correct to say that only during toga requirement it will supersede that lever selection? If the FMGC signals
Auto thrust angle of attack. High angle of attack condition.
Okay. High angle of attack. Okay.
Yeah, alpha floor or high angle of attack, whatever you call, it will supersede the lever position.
Okay.
And that is automatic, not manual.
All right. Okay. Thank you.
And I have asked the pilot, even it is applied toga thrust, but they will not move the lever to the toga. They will leave the lever wherever it is. They will simply use this button. Nothing more than that.
Okay.
Just to disconnect, and that's it. Keep silent, observe the aircraft.
Okay.
Clear, sir?
Yeah. Thank you.
Welcome, sir.